So maybe a new last call is good.
Yeah, maybe so.
Yeah, I mean, I'll leave that to you, of course. Yeah, that's up to you. Uh, and for the next two, I'm gonna ask about adoption. I presented them in San Francisco,
Okay.
or someone else presented one of them in San Francisco. At least they were presented already. For Torles's draft, I don't think we are ready to adopt it, the RTS. Um, Hitoshi's, yeah, maybe we can consider adoption. Not, I'm a little unsure. I think actually I think in his slides it says something about next steps and stuff. I think there's more maybe, so maybe no adoption yet. And Jeffries is just a new draft.
Yeah. Okay.
Yeah. So
There's one more draft that I found. I gotta send it to you, but I kind of like the MOFR. I just totally forgot about it, and I'll find it. It's a year draft and somebody else that we worked on it like a year or so ago, and I just kind of.
Oh really?
I'll find it. I'll let you know which one I'm talking about. I can't remember what one it is, but anyway.
Yeah.
Yeah.
Yeah. Have you used the pool here, by the way, or noticed the other day that there's like an artificial beach and all kinds of stuff there here?
Is there?
Yeah.
I haven't checked it out. I'll have all day tomorrow.
Yeah,
Maybe I'll
the
check it
beach
out.
looks really nice. There's like even like lifeguards and
Oh, really?
lifeguard towers.
Oh, really?
And stuff. Yeah.
Is it along the river?
Yeah.
Okay. I'll check it out. I don't leave till Sunday, so.
Yeah. Yeah, let me just show you something. I guess
Should
we're
probably get
supposed
started
to
here soon.
start. But let's see. If I do satellite here, how do I do that? I know how to do it on my phone. Anyway.
I'll look it up. We gotta.
Yeah. So we are here, and over here somewhere.
Oh,
There's
really?
some really
That's pretty close.
really big beach and really big kind of pool, but it looks like you are in the ocean, kind of.
Oh, funny.
And also an additional pool.
Okay.
Yeah.
I'll go
It's
check
really
it out.
nice. Yeah.
Yeah.
Okay, let's get
We're gonna
started.
start. Yeah.
Yeah.
Oh, it is. Okay. Okay.
That's
We'll
gonna
talk
be
about our
funny.
families and our music preferences.
Yeah, no, good
Okay,
shot.
go ahead. Yeah, it's all you.
Okay. Yeah. Okay. Welcome to PIM, everyone. So we got a large enough room today. Let's get started. So, okay, this is the note. Well, I hope you have seen this already. It's already Friday, so. Okay, next one. Yeah, I don't really see the slides. Okay, thanks. All right, this is the agenda. Any comments on the agenda? Anything we should change? Are we good? All right. By the way, are you checking the queue and stuff, or do we see that here? I guess if there's an yeah. Okay. So next slide. Then yeah, I guess I can run this too. Yeah. Okay. So we'll start on the status of the current working group documents. So we have been working on progressing IGMP version 3 and MLD version 2 to internet standard. So we have these 4 BIS documents here. We did do a last call on the first 3. And we're all good, I think, except for one issue raised about fallback to version 2 when you see an older query. And we're going to discuss that later in this meeting. We're also revising 11.12, which is the original like host. What's it called? Anyway, it's like how a host should do multicast. It's like Steve Deering's RFC from very long back. The thing is, it talks about host requirements for multicast, but it only talks about IPv4. So we wanted to add a few things to that and also progress that RFC. Then we have 2 drafts about DR improvement or backup DR that we still should work on at some point. The drafts have just been idling for a few years. Okay. But yeah, please speak up, add yourself to the queue if you have any comments or questions on anything. Okay, so we'll continue with some more drafts. We got some point-to-multipoint drafts that we will discuss today, shortly after this. Also PIM Lite and some joint print extensions for Lisp as well. It's on the agenda today. Then we got this MOFR, whatever it stands for, but TILFA draft. So I believe we might be ready for doing a last call for that. The authors believe it's ready and asked us a while ago if we could do a last call. So I would like to check, if you believe it's ready to start a working group last call. So we're going to start a poll for that. So this is not the actual last call, it's just whether you think it's in good enough shape to start a last call on the list. And we'll also check this on the list, of course. So yeah, if you believe it is ready for last call, please answer yes to this poll. Otherwise, answer no. And yeah, there's also a no opinion option, I see.
Is that going to show up on the recording, or do I need to?
Recording's not up.
Like, if we watch the video later, will we be seeing this on the screen?
Yeah, it pops up on your screen, you select it, and then when you say it's done, all that goes into the notes.
It does automatically go into the notes? Oh, okay.
Okay, great.
Yeah, you're almost not needed.
Okay.
Okay. Yeah, we can try to, of course, say the numbers, but that is good. Okay, so I think we're good. About 5 people say yes, 4 have no opinion, and no one is saying no. So we'll take it to the list then, and start a last call if there's no complaints about that. Okay. We got an EVPN multicast Yang draft. This is something that normally would have been done in BES, but they have a very, very busy, what should I say, they have a lot of documents there. They're struggling to cope doing all they should be doing, and we got expertise with Yang multicast models here. So the best chairs, we discussed it with them, and we figured it was best to do it here in PIM. We should still have it reviewed, and when we do a last call, Beth should also be looking at it, but at least we are doing the main work in this working group. But yeah, we're not this. Is that? Yeah, that is on the agenda also, so we'll talk more about it soon. And then we got an IGMP MLD snooping Yang model draft not discussed today, and lessons learned that we will discuss later today. And finally, let's see. Yeah. Oh yeah. Okay, so we got several documents that we recently adopted on multicast discovery. ZeroConf, what you would want to call it, but we're not discussing them in this meeting. All right, that was the status. Any comments before we start on the agenda, on the presentations? Okay, let's go.
You got several presentations here.
All right, perfect. So the first one is PIM Lite. If you can go to the next slide, please. So we did have a interim call with Stig and some of the other folks. We did change some of the paragraph sentences in the draft to make it more readable. Yeah, it was great help. Thank you. But there was no major conceptual changes. There were some additional information that was added for security purposes. Basically, the security stays the same as the previous RFCs for PIM, SSM, and SM. And we can use the ideas in those RFCs for security consideration as well for PIM Lite. So in essence, again, there were some, changes for better reading. Nothing major has changed in this draft in version 2 compared to version 1. Next slide, please. So I guess the question is this good enough for the working group? Is this clear enough? Something that we can agree to go to the last call, or do we need to have some additional work put into this draft? I think that's where we are right now.
So we'll start, we're going to go ahead and start a poll.
Okay.
She's going to chair it. So, yeah.
Sure.
Sanizang ZTE, as a shareholder of this draft, I think this draft has been good shape, and thank you for the authors for your valuable work. And if I remember right, all the main comments has been all addressed. So I think this has ready for working group last call. Yeah.
Okay.
Yeah, I can maybe add that, yeah, both Mike and I are co-authors of this draft, so that's why we are having some help with this document. Yeah. All right. Okay, yeah, so we're doing this poll here. So please respond whether it's ready for last call or not.
Oh, yeah. Okay, so thank you. So we'll be pinging you in the next couple weeks to issue the formal working group last call on the list. We've done this informal working group last call. There's 7 people in support of it, which looks pretty good. But since you're chairing this one, you're going to have to send an email to the working group and ask for a.
Hey, Mike.
Yeah. Sandy is going to chair this working group last call for this draft.
Okay, I can try to start the working group last call for this draft. And if I should ask the mailing list for some feedback at once.
Sure.
Okay. But I think if there is no response, it means that there is no objection, right?
Yeah.
Yeah. Okay.
Thank you. Yeah.
I will try.
Okay. Thank you.
I will do it.
Yeah. Yes, Tigger. Yeah, I would say in general, it's kind of hard to get responses to working group last calls. I wish people would be more responsive, and we should try to beg people to respond if we can. But yeah, it's difficult at times to get last call responses. But yeah, see, we got 9 people saying yes here and no no's or no opinions. So we'll stop the poll then.
Great. And we've got 2 more polls coming up, so just be ready. Okay. We're good with that one.
Okay, so point to multi-point policy ping. Next slide, please. Just to give you a little bit of overview of what's happening in this whole point to multi-point policy domain, if you will. So we did have a RFC 9524 for the segment routing replication seat and the replication segment. So basically, as you folks know, this RFC talks about the replication segment in MPLS cap and in SRv6, both of them. Now that has gone through, there is two other major drafts in PIM. So the one for SR point-to-multipoint policy talks about the policy itself. What the policy is basically a replication policy that you can bind to a provider tunnel, whether it's a PIMZ sitting under the MVPN or whether it's a tunnel that is being used in the base routing or global routing table. Basically, it gives a binding point between those replication segments in RFC 9524 to the application, whatever the application is. So that's what the SR point-to-multipoint policy is all about. And it does, I think a couple of drafts ago, we did add the SRv6 component of the replication segment to the PIM SR point-to-multipoint policy draft. We have not added anything new for the past couple of IETF. And the reason for that is we've been working hard on the PCE part of it. There might be some changes in the PIM draft, which I don't think so, depending on what happens in the PCE working group with the PCE solution. Again, I don't think that's going to be the case. I think, as you will see later on, the PIM SR point-to-multipoint policy is pretty stable. So the next one is the ping itself. Again, we do have an implementation for that, but we are open to discuss. I think one thing I want to bring up right off the bat is there are some implementations for this point-to-multipoint policy. So, if there are any comments, concerns, please bring them up right now, because otherwise, as you guys know better than I do, if the code starts getting typed into all these routers, then changing it, not trying to be difficult, but it's going to be harder, right, to change these drafts. So now is the time to bring anything into the equation. So there's a comment. You want to go, or Jeff? Yeah, might as well have an open conversation.
Yeah. Okay. Very quick clarifying question. The last bullet, the IDR SRP2B policy, need to progress the work here, or?
No, sorry, that's just my broken English. I think I'm trying to say that we are trying to progress the work, as in revive the draft again. We haven't worked on it for a while. Sorry about that.
Okay.
Thomas Eckert. Yeah, sorry, haven't been finding time to follow the whole stuff at all. Just one fairness question: has the implementation and known support for all of this reached the same level that we had to reach with beer to go from experimental to standards? I guess this is all asking for standards, right? So it was just wondering, right? Maybe, if there is not enough, maybe it should also start out as experimental. That's kind of the only process question coming to mind.
So, I mean, I'm not going to talk about other vendors. I don't want to get in hot water, and I don't want to get in trouble. But like on Nokia side, we do have live customers that they do not use the PSEP part of it. They just use the Yang, and they kind of connect the replication segment to a unicast SR policy or a seat list. So yeah, there are live customers that are just using the Yang to make this.
I think the main part is the hardware, right? So the replication through a SIT or so in hardware, that seems very likely to be supported already by multiple vendors.
Yeah, so again, great point. I think for when it comes to MPLS, for all means, it is same as LDP or RSVPT, right? When it comes to MPLS.
Yeah, that's what I don't know, right? So I haven't followed, but yeah, that's fine then. Thank you.
Yeah. So again, just to be clear to everybody, even though we call it a replication segment, when you go into the data path, it is by all means a MPLS label that has a bunch of OIFs. So, I mean, I think Jeffrey going to talk about it. So at the replication points, there are states like MLDP or point-to-multipoint RSVPT. When you try, I shouldn't say the sexy part about it is it tries to marry unicast and multicast. So you can connect two replication segments through a unicast domain via unicast seed list or via unicast SR policy. So as you will see in the other draft, other slide that is coming up, the feedback we are getting is that having a multicast tree end-to-end sometimes is a problem child. Having this marriage between unicast and multicast, so some portion of the network, you can go with a unicast tunnel that is kind of binded to your multicast seed. It is very helpful to them. Anyway, I'll talk about that a little bit later on. Next slide, please. So I think first thing about this draft is it only addresses the MPLS OEM part of it. It doesn't address the SRv6. So the SRv6 OEM part of it, there are some paragraphs sitting in the point-to-multipoint, PIM point-to-multipoint SR policy. So we put some paragraph in there. I don't know, I need to talk to the other co-authors to see whether we need to have a draft for SRv6 on its own. But this one specifically only addresses the MPLS part of it. We added some security section under the draft. Again, feel free to go read it. But like anything else, because this is very close to MPLS, MLDP, or point-to-multipoint RSVPT, we could, from security perspective, we could kind of piggyback on the existing RFCs. And I guess last but not least, there is implementation of it, at least on the Nokia side. Next slide, please. So I think the MPLS working group has been involved in this. I think chairs here and me myself tried to ping them a couple of times. I didn't get any comments. And the fact that we have implemented this kind of gives us a fuzzy feeling. But yeah, I don't know whether this thing is ready for last call or how do we want to proceed with this draft going forward.
Yeah, I think it's kind of a long discussion that covers a lot of things, including recharting. But just a reminder, we did have a long discussion with MPLS working group chairs and agreed to working on these documents. Now that the replication segment draft is a published RFC, I don't see any reason as a chair to not progress these drafts. This one and the one that you're going to be presenting next, unless you see it differently.
So you mentioned something about OEM parts that may need a separate draft, and so I'm wondering, is it a chance that you will want to take some stuff out of this draft or make some further changes to it, or
for SRv6, you mean?
Yeah.
No, I think this one, and that's why we separated, because I think there are two different beasts, and even on the unicast side, when it comes to SRv6, there's a different OEM draft than MPLS. They're just way too different, so I don't think there's going to be any change.
So the way you see it, you don't really plan any further changes?
No, and that's exactly, we fell into the unicast part of the trap where you try to do segment routing as a whole between MPLS and SRv6, and it becomes too complicated, right? So this is exactly why we separated the two, because we feel point-to-multipoint policy with MPLS is really ready to go. So, why make everybody's life miserable?
What do you think?
It might be ready. So by the way, if we do a last call, I guess we should also send that to Spring Working Group for them to review. And
yeah, the way that we kind of worked it is that these are our documents, but we will be running everything by them just so that they know. But the likelihood of them responding, like you said, is probably pretty low.
Sure. Yeah.
Okay, so
Okay, so yeah, maybe we should
Let's do
ask
it.
the room about last call.
yeah,
Do another
let's do it.
poll.
We'll do this, the ping one first, I guess. That's what we just presented on.
Yeah, so we have this poll now whether you think the point-to-point point-to-multipoint policy ping is ready for last call or not. So based on, yeah, if it turns out that people think it's ready, then we would take it to the list next. Yeah, lots of no opinion votes, I see.
Okay.
Yeah, so not too much responses here, but as long as there's, as long as there is no one against it, I would say we can do a last call on the list, and people will have the chance to speak up then, of course. Okay, so we got they got all the polls down there.
Oh, yeah.
Let's see. So okay, so we got 1 yes and 6 no opinion. 0 no. Okay. Then we'll do the same for the other draft, I guess.
Same thing for the draft, yeah. We'll issue a separate.
Yeah.
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 Yeah,
So,
we might
go
as well
ahead.
do the same thing for this
Yeah,
one.
sure, yeah.
So maybe next slide. Yeah, just to give you a little bit of status of the draft. Again, we haven't made much changes to the draft. We think it's stable. There are implementations out there, whether it's via a static configuration Yang, or whether it's via PSEP. There are implementation. We are working on the common PSEP draft. So when that's ready, multiple vendors can program the replication segment via same PSEP communication between the PCE and the PCC. One feedback that I can give you is that SRv6 being the new sexy thing out there, there is interest in a multicast solution for SRv6, and this thing being a SRv6 replication seat kind of fits well into that domain. And the general feedback for the working group is we get a lot of feedback that having a multicast tree end-to-end going through ISPs or through some segments of the network that is we are mandating multicast, that is a pain for some of the operator out there. So they do like this flexibility of marrying multicast and unicast together. So wherever you need to have unicast forwarding, you can very simply, by adding like a SR policy or IPv6 header on top of your OIF outgoing interface, you can shoot your multicast traffic multiple hop over a unicast domain. So this is something important to them. And they are really giving us feedback that they might need only a couple of replication points throughout their network for caching or for sending data into edge cache points. So, I mean, this technology, whatever technology that marries multicast and unicast, is beneficial to them. Next slide, please. Yeah, again, as I mentioned previously in the ping, I think this is a point that if there is any suggestions or comments, please bring it. If you haven't read the draft inside out, please do it. Bring in the comments and the suggestions. And, based on that, we want to see whether it's ready for the last call or not.
Okay, we just started a poll. So same person thinks it's ready.
Oh, one more.
Hey, we got a few more.
And it's not Human that is saying yes, I guess.
It's a V12. It takes a while for it to ramp up.
Okay, there's more yeses here actually. Yeah, looks like we're good. 3 people yes, 1 no opinion, 0 no. So yeah, we'll take this to the list, and yeah, we'll also look into what review we need across other working groups.
Thank you.
Thank you very much, Chris.
Yeah, thanks. Is it me or? Yeah, it's not me yet. Right, Horlis is also. I'm way down.
Hi, Mike. Can you hear me?
Yes.
Okay. Good morning. I'm Hongji from Ericsson. Now let me introduce some updates about the EVP multicast young model. Next, please. After this draft passed the working group adoption call, we have updated. We have done some updates according to the comments. Next, please. The draft update 1 and the Ethernet segment identifier type defined in the IETF Ethernet segment young has been deleted, so the type of the leaf needs to be updated. We have changed the type to the young hex string length 2029. Next, please. Update 2. When it supports either HMP proxy or MLD proxy, type 6 to 8 root might be added under the EVPN rules. So we add the following if feature statement. If feature EVPN IGMP proxy or EVPN MLD proxy, this tree will we will have this tree. And next, please. But the hierarchy has not changed. This is the details for the 3 new BGP EVPN rules. Okay. And next, please. Well, we welcome more comments. Thank you. That's all.
Any questions for Hongji? This is a recently adopted draft. If not, thank you.
Thank you.
Tourless. And it's the, yeah. The BIS, the 1112 BIS.
Oh, the 1112. Okay. Right. So this is just a short status update of no work happening. No, a little bit. Yes. Next slide.
Sorry.
So this is the slide. So yeah. So just small bug fixes in the text. And I think the main open issue is whether we should refer to the existing IGMP v3 and MLD v2 RFCs, or already hopefully put the new versions in there and kind of create a cluster. I'm totally open to that. I don't think we need to rush this document out to get full standards track again before we do the same with the two other drafts. So I do think functionally for us and work-wise they are a cluster, and I'm missing more feedback for you know, the which we'll have at the discussion of the 3376 bis, what we do about them. And yeah, so the main point I think is just to find more reviewers. I don't want to look at anybody in particular here directly, but so that's what I've been trying to do. But you know, most people don't even remember what IP Multicast is, so there aren't that many that would be helpful, other than I guess the ones we would get from the IESG as soon as we do pass it working group last call, right? So I think this is just something we need to keep alive to figure out what to do with our cluster, and then move it on. And yeah, please, you know, review it if you can. It's a nice read. So the guy whom I learned marketing multicast from called it the Bible of multicast. So that's why it's that was Bo, right? So yeah, that's it, right? So did you have a chance? I mean.
Hey, Bill Fenner, Arista Networks. Yeah, I have not yet had a chance. I hoped to this week, but
Sure.
I will put my hand up and say I will review this document.
Excellent. Thank you.
Yeah, Stig here. So the other BIS documents, we already did our last call, and we have some issue we want to discuss about one of them, but I think they should progress pretty quickly. So I think referring to them, referencing them would be fine and not really any delay. Yeah, so as an individual, I think it's a good idea to reference the BIS documents. Yeah.
So this is also a document that we're not rushing forward. We're taking our time with and creating a story with regards to the historical perspective of the development of multicast protocols, some of the lessons learned and the challenges that we faced. And the hope is for people, as they've expressed to us, particularly in the IETF, to understand, you know, why are certain protocols no longer being used. And so for the last, I don't know, maybe a year now, we've been slowly working on this draft and adding protocols and developing this story. If you can go to the next slide. Yeah, if you can go to the next slide as well. I've shared that one a few times. Yeah, so this is what it currently looks like. We added, before each IETF, we just have as a goal just to kind of add a new section. And so this time we added AMT and TreatyN. AMT was mentioned in the previous section, the all or nothing problem section, but then we developed it for a section on its own. Lenny's kind of been going on a tour lately, and he shared a really good presentation at the recent NANOG, if you're interested, as well as a podcast talking about these two things. So it kind of continues to further that story of the all or nothing problem where you have to have all your routers supporting multicast. And if they don't, what do you do? Well, you can tunnel around it in a variety of ways. And AMT is one way to go about doing so. And a particular solution called TreatyN, which is being developed in another working group, MOP, I think it is something that is being architected. Greg.
Oh, I just, yeah, you hear me? Good.
Yeah.
Greg, NSRC route views. So I owe you text. I want to acknowledge that.
Okay.
I owe you text.
Okay.
And I am working on it. So I actually wrote a little bit on the way here when I realized, I
nice.
haven't published anything yet. So before Vancouver, I hope to ship.
Okay. All right. It's on the record. Very good. So we've received a fair amount of feedback. Again, we'll be probably working on this for a while. So we open it to anybody. If you see a missing protocol that we're not addressing yet, if you think the story is not quite the way it should be, just let us know. Hitoshi?
Hitoshi Asada. So what do you think about discussion about multicast address schema. So, and I remember just 3 or 4 times before the meeting, there was some proposal about address, dynamic address allocation and so on. So that was actually previously discussed like MS Nippon and so on. So we had a lot of experience about that kind of dynamic address assignment schema.
Right.
But still, someone who maybe don't know our histories, and they may also want to try the very, very similar approach, but we already had a discussion. I don't know, it was actually failed as a deployment consideration or not, but anyway, we had the experience. So maybe it's good to point out, we already had several approach, and why it was successful or not successful, I'm not sure. So maybe such kind of discussion is really useful as well.
Great point. I fully agree. We will add that for the next one. In fact, there's some drafts that we've recently adopted in this working group on group allocation, address allocation, and how to disseminate that. So I think that's part of the story, and we can talk about the historical perspective.
Yeah, and also you said SD and SDL, but actually SD and SDL is not a protocol itself. So as a protocol, if you want to talk about that kind of SDL or SD, maybe it's also better to show the SAP.
SAP,
and, yeah,
sure.
SAP, we had a lot of problem about SAP announcement.
Right.
And it's something like a flooding, and we had maybe problem, maybe. So maybe this kind of historical topic is also useful for the maybe future work, which is related to the address assignment and so on.
Great point. Will do. Thank you. Any others?
I think I sent a couple of different text options to you a long time ago, so I haven't tracked if any of that got included.
It
or
did.
not.
Yeah, it did. And we put you in the contributors. So yeah, we included portions of it anyway. I don't know if
Yeah.
we've covered everything.
Yeah. So
Thank you.
I think just in general, right? So I think the shared versus source tree, right? So I would love to see in the whole director, of course, SSM as a title, right? So just from the high level structure, right? So just me with a marketing head on, right?
Sure.
So,
Yeah, we do cover SSM quite a lot, but maybe it needs to be in a title of a section. All right, we need to move along. Thank you.
Yeah. This is Stig. So we've been doing working group last call on these BIS documents to progress IGMP and MLD to internet standard. And for the IGMP v3 document, there were some comments about fallback to IGMP version 2. So next slide, I think. So the issue is basically that, as I understand it, is that if there is some device on the link that sends an IGMP version 2 query, then everyone falls back to IGMP version 2, which means that you can't do SSM anymore. Because when you see an IGMP version 2 query, the query falls back to v2 if there's multiple queries, but also the hosts will fall back to using IGMP version 2 for all the groups. So it can be a denial of service attack, I guess, if someone sends a v2 query intentionally, but there's also been issues out in the world where often, in various deployments where some device for some reason unintentionally have been sending v2 queries. It could be devices that are not managed by the same organization that for some reason is present on the link, or it could be configuration mistakes, or it could be multiple things. So when we did the last call, Torles was the one that brought this up, and happy if you want to comment on this, Torles. But there were several people chiming in, about this. So the question we have now is, yeah, we have the section 7.3 on this slide, which is the actual text from the RFC. The question now is, as we progress this, do we need to add some text or changes to the document about this? Or do we think that this is kind of, yeah, sort of sufficiently covered? Maybe next slide.
Okay.
And yeah, Trellis.
Yeah, I mean, at the risk of somebody being concerned that this is a new feature then that we're adding in there, right? I've seen it, just often cause things, right? So even, widely distributed things in Europe, right? It's like, TV, satellite TV, Sat IP, which in Europe has big satellites, right? And that stuff was failing because there were just, IGMPv2 queriers, right? And this was all demanding IGMPv3, for example, and also similar things. So I would really love to see that the conclusion would be that hosts should ignore IGMPv2 query and lower queriers, and must have a configuration option, or to allow them, right, for automatic failback, but that the default behavior should be SSM safe, so to speak, right? That they won't fall back in the presence of an older query, right? That is the extreme, right? So that gives us SSM safety, and anything shorter of that, because the one text you had below was just the router behavior and not the host behavior, right? The problem is the host behavior. You want to have the SSM reports, right? So that's the big problem we have with all this backward compatibility. I mean, obviously the real thing would be to remove the whole bloody backward compatibility, right? But so we're not ready for that, right? So that's why I'm saying the best one would be to have, must default to ignore.
Right. Yeah. So
all the queries.
Yeah. So yeah, speaking as a chair first, I think. So at least we are revising this to internet standards. So we can't, I think, to make any major changes. And we would like, I think we need to make sure that if you are compliant to the current RFC, that you would still be compliant with the
that's a good question, right? So I mean, if we do something for full internet standard, I think one of those things is also to eradicate small bugs. I would consider this to be a small fatal bug.
Yeah.
Right? Because I mean, the main reason why ultimately after the researchers went away in, I think, 2000, IGMPv3 was there for SSM. And basically from that point on, we've been dragging along with this bug in the backward compatibility.
So I believe we can make recommendations, have mays, maybe even shoulds, potentially something to consider. The only thing is, I don't think we can have like a must in there that say, you must do something different from the previous RFC.
Well, maybe we can get ourselves negotiated down to a should in ISG review, right? That's fine too.
Yeah. Okay. Yeah, Bill.
Bill Fenner, Arista Networks. I might have some history here. I mean, as we all know, like the 90s were a heyday of the router knows everything, right? And the hosts are going to learn from the router. Like, look at IPv6 RAs. It was the same kind of deal. Like, we don't want to have to configure hosts for any reason. And the network is the authority. And that's where all of this auto query stuff came from. But, at that time, like, we totally didn't envision the kinds of networks that people actually were going to deploy, right? We all envisioned networks where like routers were tightly controlled and nobody who would put an extra router on a network that wasn't the one that they provided, all of this stuff. So I agree with Torles, like it makes sense to try to do something. However, like the obvious problem with that is that like trying to do something affects every host in the whole deployment, right? Host OSs are sometimes the hardest to get upgraded. So, it's a sticky problem. I agree that there, you know, if I, I don't know what to do.
So I mean, it's yes. So if we, let's say, do the must or the should, right, and you're not complying yet, right, you're still compatible compliant with the old IGMPv3, and then you basically add sometimes, you know, in the next 10 years, that fix into your source code, right? So, and I don't really know what the big problem there is. Yes, it would impact everybody, but it's by far, you know, a small fix, I think, in the software. So.
No, I mean, right. I think it's fine to go forward changing it. I don't know what that does to the standards level. I'm not, you know, I'm not going to have an opinion on that. But I think reality is different than we envisioned 25 years ago. And so it makes sense to look at real deployments, real deployment problems, and say, that auto compatibility was a great idea if the world looked like that, but it doesn't. So let's figure out something that works.
Mike McBride, I fully agree with everything that you two just said, but I disagree. I think that it should be dealt with in a new document. I mean, the points 1 and 2 is personally what I think we should do. Do nothing, let this document proceed. And if there's issues, which there are, which we've known for a long time, just deal with it in a new document. And that's kind of what's pointed at. That's what this work group needs to decide either now or on the list is, do we do nothing, just proceed with the document, which is my opinion is, or do we get more involved in adding? Oh, there's more line. Okay. Anyway, just wanted to add my opinion.
I don't know. Who is this? Oh, it's me. Okay. Oh, yeah.
There's no chat that kicks me out of the list. So.
Okay, Hitoshi Asada. So this problem is actually it's known like more than 25 years ago. So and actually my kernel BSD implementation, which was imported in a Kame stack, and also the currently Linux, I got the information about it in a mailing list. So Linux also support that we can just statically configure that backward compatibility can be just ignored by host. So the easiest way to address the issue is to have the function, not the function, to have the mechanism to configure just ignore that kind of fallback message. So of course this has a risk. Of course, if the some courier or Ford actually, well, this is a little bit different than discussion because I send it to the mailing list. So if the Ford and query are different, what happens? So anyway, so this is a different story. So I'll go back to the original comment. So if the host has such kind of function and the router must require the old host to falling back to the V2 mode, then host must follow that decision. But if the host already have the confidence that we don't need to fall back the IGMP V2 or V1, then they should have that kind of configuration function and just ignore such kind of fallback function. So already BSD, Linux, I remember both supported that kind of static configuration. I don't know other OS, Mac OS or Windows, I'm not sure, well, iOS, I'm not sure, but at least such kind of major operating system has such kind of configuration option. So the simplest way to address the issue is to add the explicitly say we can have the function to just ignore that kind of fallback function by configuration. And the problem I got was that, okay, so which should be the default value? So the ignoring that kind of fallback is the default, or accepting that kind of backward compatibility is a default. I don't have a strong opinion about that kind of default behavior, but at least it's the easiest way is that we can have such kind of static configuration. This
Yeah.
is my
Yeah. Okay. Thanks. Yeah, I want to add myself to the queue, but yeah, go ahead. Go ahead.
Yeah, Nicola Leimann, Deutsche Telekom. Just to add to the discussion, we had those problems for a couple of years, and there are still two major issues. One is that the IGMP version 2 queries are not going to disappear because they are not in our control, and you will see people with bunch of devices inside their home networks basically breaking then IGMP version 3. The second thing is we talked to the router vendors providing the CPEs for the networks. It's an open market in Germany. And they were always referring to the RFC for IGM version 3. And they said, okay, we have implemented it as in the RFC. We know that there's a problem, but we are not going to fix it because then we are not standard compliant. So I think it's a good idea to have at least some kind of sentence or information that there is a behavior where this kind of problem can be fixed.
Okay. Yeah. Thanks.
So I mean, anything we're changing, is potentially, as Bill said, some new code that need to be implemented. But I mean, maybe we should just look at some other, RFCs that went from proposed to full standard to see, how far they could drive, fixing bugs and other stuff. That might be, a good tedious job for somebody, or we'll try to find some old ADs and ask them.
Yeah.
Oh, wait a second, old ADs. Where am I? Oh. Right, so.
I already volunteered, Dr. Owen.
Yeah, right, exactly. So
Yeah.
and I'll try to find some others, right? But yeah, I wouldn't be so concerned about this as Mike is, right? Especially with, I think, the deployment experience that we have. Maybe those are things to these deployment experiences from Nick and Hitoshi that, right, so might help, right, to swing the pendulum into the direction, right, that it's a configuration option for the hosts, right, and B, the whatever the right thing is for the default, right, should for the default maybe after this discussion, and there is one more thing, which is that basically whatever so the major use of SSM is in embedded devices, right? Set-top boxes, for example. And in that case, you can already also say, applications may have, the, mechanisms to overturn whatever the OS's defaults are, right? So that even you're buying set-top boxes with OS from wherever that is, right? There are a couple of vendors. And then if the application, right, the deployment in the IPTV environment chooses to use SSM, then the application itself can change the default, right? I mean, there are a lot of ways to get around making this something mandatory in the protocol itself, but we can add text to give recommendation on how whoever wants to rely on SSM can get that safely.
Yeah. So speaking as an individual, so yeah, well, first of all, as a chair, I guess, yeah, I think it's a good idea to check with the ADs or ISG to see, what how far can they go, kind of in what we put in the text in the new document. But yeah, as an individual, I think it's a good idea to add some recommendation and say, like in capitals, like we recommend whatever, having a knob to whether you fall back or not, or we can maybe recommend using a different default potentially. Have to think about the wording, right? But if we do something like we recommend, that means that you are still compliant even if you're not doing that, right? But it would hopefully be strong enough to tell people, oh, you should really change your implementation to follow this recommendation. Maybe we can do a should. You can also not implement a should and you're still compliant. So, yeah.
And I think the second recommend is, right, applications that depend on SSM, depend on being SSM receivers, right, should have an opportunity and to ensure the right default.
So,
right?
So let's
which
say
kind of pushes the thing up to the API, which we're not responsible for anyhow.
Right. So let's say if you have a host stack that has some kind of way of configuring or suppressing the fallback, right? If the application or the set-top box vendor, whatever, can make sure that is configured, then we should be okay.
Especially in the, in IPv4, we don't have these well standardized 239 SSM ranges, right? So it's not even that the OS, like in IPv6, knows when something is SSM, right? Which is why it's good for the application to be in control of saying this must be SSN.
Yeah. I know I'm, suddenly thinking of possible new things like some socket API thing where you can say force SSM or whatever, or you could do stuff. But the problem is, of course, getting stuff implemented and shipped, and it might take a decade or something.
But I think we're not responsible for that. So those
Yeah,
things
sure.
might not even need to
Yeah.
be capital letter, right? Because we may not be responsible for the API. But I think at least
Right.
revert what Nick was saying,
Yeah.
that we do provide the wrong guidance up front, right? To basically force vendors to do the wrong thing.
Yeah. But another thing I would say though, if some device comes up using V2 and the device is not supposed to be there, I mean, you have possibly all kinds of problems, like if it becomes the DR and it doesn't support or understand the V3 reports, or it has the wrong RP config or no RP config, for instance, things like that can easily break multicast as well. But yeah, I mean, we see a clear issue and there are things we can do. So I personally support adding some text there. Okay.
Do you hold the editor pen right now?
And Brian is the editor. So
you seem to have good recommendations for possible text.
yeah, maybe, yeah. So we should ask Brian if he has any suggestions as well. But at least, yeah, speaking as a chair, I guess, I would like us to conclude on this in a few weeks, and it would be good if Brian, maybe myself and others can propose some text and we can conclude on something shortly, because I think this is the only thing holding up the document now. Okay, thanks.
So are we, well, as you mentioned, follow this up on the list, but are we assuming in this room of the conclusion that we will do point number 3, we will add some succinct text to the document to clarify this? Is that the consensus we're reaching?
I think it's do nothing, proceed. Yeah, I think
Bullet
number
3.
Recommend, right? So the should, right? So that we're still compliant if we don't, right? But that we do give the right direction, not the wrong one. Yeah.
Okay.
Do we need to do some poll, or we'll just continue the discussion on the list?
Yeah, let's continue on the list.
Yeah.
That was, yeah.
Yeah.
Okay, so what do we got next here? Join PIM extensions.
Yeah, so this draft is about joint PIM extensions for Lisp. I'm one of the authors. So we did an extension for Lisp maybe 5 years ago or something, and that's been working fine. But you see that when you're using multicast in the underlay, we would like to use the existing extension in a slightly new way. Next slide. So this has been presented a few times. I think there's a slide a bit sooner.
Sorry.
Yeah. So we have been presenting this several times already. It doesn't have all the details here, but basically there is this join print attribute called an ETR rlock attribute. And the idea for unicast was to say, this is the end cap you should use. This is the tunnel destination of multicasts. With multicast in the underlay, we want to use the same attribute for specifying a multicast group address. It's still the destination address of the outer end cap of the IP packets. It's just that it's now a multicast address. So this went to last call maybe a year ago, maybe a little longer. Alvaro had some feedback then as part of his review. Main thing, he was saying that there was no actual specification how to use the attribute. The draft at that time more or less just said, it's the same as before, we are just using a multicast address. So in this version now, there is like added text to say when to add this attribute, what to do when you see the attribute, and so on. So as an author, I believe we have addressed the comments that Alvaro had. And so it went through last call without any comments from this working group. We asked for publication. Alvaro had these comments that I think are now resolved. So yeah, so as an author, I would like this to proceed. I don't know how best to proceed, but Mike.
Yeah, so should we, right now, just do a poll and then we can do the same thing on the list? Just to see if it's ready to,
Yeah.
okay.
Yeah, you do. Yeah, whatever you think.
Is that what you think?
Right.
Okay. All right. Sounds good.
Yeah.
All right, let me get a poll real quick.
Yeah, Torles, you're not in the queue, right? And there's maybe someone else in the queue too. I know you're just permanently in the queue for when it's needed.
Oh yeah, I can remove you. I don't know how to get rid of myself.
Yeah, I can maybe add some background here. So we did the original draft in PIM and also this in PIM, even though it's Lisp related, but it's mainly because it's an extension to PIM. But it was discussed with the Lisp chairs, and also the last call was cross-posted to Lisp and stuff. So yeah, whatever we do here, we want to keep Lisp in the loop just in case they have any comments.
Would we need to see would I need to CC Lisp on the
Yeah, I
work
think
group?
that's
Okay.
a good idea.
All right. Okay, so I'm going to end the cube. So we have 4 in favor of another working group last call on this, and 2 on no opinion. So we'll go from there.
Yeah. Okay. Thanks.
PIM, PFM.
Yeah. All right. Yeah. So this was presented by Ananya in San Francisco, and I'm presenting it again today. Next slide, please. So yeah, the idea is fairly simple. We have this PIM flooding mechanism that floods messages kind of similar to BSR. And actually everything I'm saying here could apply to BSR as well if you want to do anything there. When we do this flooding, we basically send packets out all PIM interfaces, or all interfaces where we have PIM neighbors. And then the assumption is that whoever receives this will do an RPF check and accept it only on one interface, and then forward it out all interfaces again. If you have multiple links between 2 routers, this means that, like in this case, there's like 3 links. That means that you will actually send 3 copies of the same message. Sometimes there could be many more links than 3. But anyway, 3 copies of the same message. Only one of those will get accepted, but because of the RPF check. So we are sending some unnecessary messages. Also, when the message is received, it's again sent out all interfaces. So we will receive it back on all our interfaces as well. And then we will just drop all of them because of the RPF check. So there's a lot of unnecessary forwarding. And the idea here is to try to improve on this. So what you would like to, what you want to achieve is basically that router A can see that, oh, on all these links, my only neighbor is a B, so I only need to send this on one link once. And router B needs to somehow know that it should accept this, even though it may not be its RPF interface, because A doesn't know which one of these B chooses as RPF interface. And also, if B knows that the message came from A, you should know that there's no reason to send it back to A. Next slide. So in order to achieve this, we propose using RFC 6395 that has a router identifier that can be put in PIM hellos. By doing this, router A can actually see that on all these links, my only neighbor is the same router. It has the same router ID, like B has a unique ID, right, that it announces on all PIM interfaces. So that way we know that, okay, we have the same neighbor, so we only send it once. And also when we receive a message, we can say, oh, this came from router A. I don't need to send it back again on all other interfaces where A is the only neighbor. So yeah, the idea is fairly simple, I think. Just one more thing, which I think might be on the next slide. Let's see, next slide, please. Yeah, just one catch is we need to know whether the other neighbor actually supports this extension. Because if we decide to only send it on one link, and that happens to not be the RPF interface, the other neighbor would just ignore it. We need to know that this other neighbor supports this enhancement to have kind of like a loose RPF check to say, I accept it from A if it came on any of these interfaces where A is, regardless whether it's my actual RPF interface. The logic would more or less be, you do your normal RPF, you see your RPF neighbor is A. If you receive a message on another link that also is from A, then you still accept it. So basically, you would use the existing router ID, but you would also have this one new hello option to just know that our neighbor supports this extension. And yeah, all of what I said could be done for BSR if there's any interest. Okay, I think that's it. Next slide. Yeah, any input on this? All right. Yeah. So yeah, as an author, I would like to ask if this can be adopted by the working group.
Okay. Then we will do a poll.
I was going to say there were lots of no opinions, but I see that's the participants count.
All right, so we have 6 in favor, 2 no opinion. We will follow up on the list.
Okay, thanks. Then I got one last draft to present. So this is another PFM draft. So it's proposing some new sub-TLV mechanism. Next slide, please. This also was presented in San Francisco, by the way. So if you look at the PFM RFC, it has a single TLV definition for announcing a source, group, and hold time together. That's all you need to announce as a source that a source is active. So that is fine. But then the question is, what if you want to announce some additional information about a source? Like in this draft, we're talking about bandwidth, that could be one, or flow rate, that could be one example, but it could be any kind of information you want to, like metadata, whatever, about some source. If you want to announce that, there's no easy way right now. Let's say if you have one TLV announcing the active S, G, and another TLV with the bandwidth info, how do you relate the two? The only way would be to put source and group address again in the bandwidth TLV. So in order to have an easy, extensible way of adding data about an active flow like an S, G, I think the best way is to actually use sub-TLVs. And unfortunately, we didn't think of this initially in the in the RFC. So what I'm proposing is basically that you have a TLV announcing source, group, and hold time, that's fine. But inside that TLV, you can have sub-TLVs with any kind of information we might define in the future. So you would have an easy way of associating that extra information with the active, with the flow. That's really what all this document is doing. So if implementations support this new way, they would basically use that a new TLV for announcing source and group that allows sub-TLVs. Yeah, okay, next slide. So this is what it looks like currently in the RFC. So you have the group, and then you have active sources for that group, and also a hold time. Yeah, and then the next slide. So we're proposing this format here, and this actually, the first one has a group and a list of sources. We could do that here too, but since it's slightly different metadata about different sources, even though it's the same group, I think it might be easier to just do source and group on its own. But here you see we can add any number of sub-TLVs for this source and group. Next slide. And this is just about this one sub-TLV this document has for flow rate, and it just has shows how we propose to encode this. This is the same as was done in the pub count RFC. If you remember that, like in joint print messages, we have a way of sending a pub count. Well, the main thing I feel is whether it's worth doing the sub-TLV concept. I could just have that in this draft. I put in a flow rate there because I wanted to have kind of like at least one use case. Otherwise, it's not really that useful. But yeah, depending on what you think, whether you support the use case or not, we could, also do sub-TLVs without this proposed flow rate, sub-TLV. Any comments? Okay.
Jeffrey from Juniper. So both this and the previous one are simple, straightforward enhancements to the same mechanism. Would it make sense to combine these two into a single draft?
We could certainly do that. If it turns out that there is support for doing both, we can do that. Yeah.
in my opinion, I think that we should define a common method or rules for how to use the sub-TLV, and the other can be combined or separately for different use cases. So maybe we can consider this, because in this chapter we found that we defined how to use the new sub-TLV, and we defined a new rate sub-TLV in it. I think maybe we can separate them, and so we can use one base structure for the how to use the new sub-TLV, and the other one for different use cases. Yeah,
right.
That's my opinion. Yeah.
Okay, so yeah, I would say, I want to add one thing is that, I'm doing the flow rate here, not just because I want an example. I think it's something that I want to do that is useful to us. But yeah, basically we can do right now, there's like three different things kind of. It's the general sub-TLV mechanism. It's this flow rate sub-TLV, and then it's the forwarding extension I presented earlier. And we could possibly have all in one document if that's what people want. I know Jeffrey suggested combining the two drafts, but yeah, you're saying that we should maybe take this sub-TLV out of this document. I'm fine either way. So yeah, we have a couple of different ways we can structure this. I mean, I can do what both of you said and say combine the two documents, but take the the flow rate out of the combined document, if that sounds good. Yeah. So I wanted to ask about adoption, but I guess it's a question how we should structure these documents.
Right. Maybe we could ask adoption of just the sub. Actually, that's kind of tricky because there's not a draft just for the sub TLV part of it. So I'm just going to ask the question. You asked it, so we're going to do it. And then we can figure it out from there.
Yeah, if I may suggest one thing, I know I'm just an author here, but if you know that if you can ask or check if there's interest in this work being done in PIM, at least we could know that much. And then if you know that, then maybe before the next IETF we could do some adoption call. Maybe ask on the list about what people think about the structure. I don't know.
Yeah, well, based upon the results of the last poll, there is interest. I did just start a poll on this particular draft. So there does appear to be interest enough to at least take it to the list.
Right.
Maybe what you can do before I take it to the list is agree with Jeffrey and Sandy and whoever else on how you want to structure this.
Yeah.
And then we can go from there.
Yeah, at least I feel like the main thing is whether to keep them separate as they are now or do what Jeffrey said. Right. Because that means whether we want to adopt one or two documents, right?
That's right.
Whether we take this out of there or not, that can be done now or later. We would still have two documents.
Right.
Right. Yeah.
Well, there we go with this one. So
yeah. Okay. Thanks. Yeah. I know not much input, but yeah. Okay. Thanks.
Okay. Thank you. Tourless.
All right, so this is a quick update of the proposal that we initially showed in IETF 118, which is an evolution of the work we've done to scale stateless multicast with a mix of SID-based approach and bitstring-based approaches. Next slide. So yeah, why were we here? So the bigger and large networks, right? So the long global bit strings in packets need to subdivide those for large networks into a group of nodes, BFER, that share a bit string with the common SI and SD. And so we need to have many of these bit strings and subdivide them up. And so that becomes an administrative and operational issue. So if we have a large data center with 100,000 nodes or so, and then a lot of customer VLANs with 10 to 100 nodes, right? And then these nodes may also move around, right? So when you have VPN mobility, for example, so those are typical example use cases. With tree engineering, with a BRTE, the problem becomes even more pronounced because we need many of the bits in the flat bit strings for expressing the path. And so the subdivision of the total bit string size into separate SISDs becomes an even bigger pain point. So that's why we set out a couple of years back to try to figure out, can we represent a bit string as a hierarchical structure that, just for every node has, a local bit string just for the adjacent layer 2 neighbors. That's what we called RBS, a recursive bit string structure. And then we started to think that maybe the problem in large networks is also that we need, like, in SR to skip over a lot of nodes where we don't need replication. So SIDs may also be interesting, yada, yada. So that led, next slide, to this mixed behavior, right? So the tree structure on the right, so every node has encoded one element, and when you're forwarding the packet, you ultimately will only have the substructure left where you, router, are on the top, and as soon as you forward to the next routers, you're going to extract the one block for that neighbor router and only forward that block. So ultimately, you have a little bit of work to do when forwarding a packet by extracting the subblock for the next hop, and then each of these blocks will basically have your instruction, right? So you don't need to look as the forwarding element at the overall, let's say, very long bit string, but you only need to look at what is interesting locally for you. And that hopefully should also make the forwarding easier. Yeah, so you get kind of the tree engineering you get for free just because you want to represent the tree. It is always tree engineered, but that doesn't mean that you simply don't derive the tree from your IGP, right? So nobody says you need to do some CSPF or complex traffic engineering. Next slide. So now what we came up with is that how do you represent on every node the neighbors, right? So one is a local bit string, as we call it, where every possible layer 2 neighbor that you have is one bit in your bit string, and if you're just a normal, let's say, data center switch, you've got 32 ports. Well, your bit string is just 32 bit long. If we basically want to go through a core router that has, just a couple of neighbors, but the next hops are remote, right? Like in segment routing, we want to go 3 or 4 hops away. Well, that is basically something where you potentially want to address every node in the network because they may be maybe several hops away. That's what we would do, a list of global SIDs. And then we also have the ability to say, well, wouldn't we want to have a local SID list compared to the bit string? And that's a simple, compression option, right? So imagine you just have, in this example here, 60 neighbors. That's 4 bits to represent the identifier of a neighbor, right? 4 bit is good enough for 16. So then you can compare, oh yeah, if I want to address, more than 4 neighbors, then it's better to use the bit string. Otherwise, I use, for example, the SID list, right? So it's all about representing the whole tree as compact as possible with these 3 different type of local indicators for your next hops: local bit string, local SIDs, or global SIDs. And yeah, so in general, I think when we were looking at general purpose cases, we felt that the closer we get to the edge, right, the more fan out you typically have. So definitely the bit string are ideal on the last hops. When you get towards subscriber, the fan out may be 100 or even more in broadband, for example. But if you go across a long, big core, maybe with rings, then, just doing some, global SIDs to hop over many routers just to get toward the edge may be better. So, you build a tree, and for each of the nodes in the tree, you can then choose what you want. So that was kind of the logical idea. But then, of course, comes the logical ideas are great, but, show me running hardware. Next slide. So what we had in IETF 118 was a P4 reference implementation on some unknown reference hardware for which everything is under NDA. That was called SEED, and the student from the university was presenting that there, also in Beer, where the expertise for these hardware forwarding aspects is. And so what we could do at that point in time was either one or the other, right? So a tree of the global SIDs only, or a tree of the local bit strings only. And then basically the proposal at that point in time, if we wanted to go with this flexibility into standardization, was to just have an indicator in the packet to choose one or the other. And then when we continued since 118 to figure out how to improve on this, we got on that forwarding platform also to the point, if we wanted to have both of these code segments together, that was actually already running out of code space on that node. So basically the student went back and we looked at it. So what they came up with was then, and that was presented on Tuesday in Beer, where unfortunately I had another stupid conflict, so I couldn't be there. But so that was basically the combination we wanted. So we can have in a single packet both the SIDs list, and we can have bitstring, except that on this forwarding platform, we couldn't recurse with bitstring, right? You couldn't have a bitstring and then forward to further nodes that also have a bitstring. So then I was going back and thinking, okay, how do we generalize that? I don't want to have something in a standard body that is based on the limitations of some, very, very low-end hardware. But of course, I would really love to have such, hardware be supportable by a standard, because that may be the only thing that researchers can do. And I think in the past, like in the 90s, we've seen, how research deployments have actually driven forward and created the big change to get multicast working, right? So I'm very much hoping that the same can be happening for beer as well, to get more interest from that side. So next slide. So the way I figure this can ultimately be done is that we do define this block for every node, flexible enough that good nodes can get all the optimizations, but bad nodes can only support a subset. And what that simply means is that in the control plane, you would have to indicate, right, this node is bad. So when you build a tree through that node, you can only choose the one option for that block of the encoding that node supports, right? For example, that this node cannot have a bit string, and then the next hops can have bit strings as well. So this is, of course, for a short slot that like this, probably way too much details, but just very high level, right? So what you're looking at up front, that is what you as the node sees, that gets the packet. The RU params is pretty much telling you what the encoding is. And then you get a list of 0 or more neighbors downstream of you, right? So your direct leaf neighbors, and if any of them has an RU itself, that's what you would forward to that node. So in the RU params is exactly what this long bit is. So there are a couple of flags, which basically has some optimization, broadcast. Deliver means the bit, this packet is also for you to receive and not only to deliver further down into the tree. Then the SID, long SID basically says, is your SID in this header a long or a short one, right? So we said global or local. Is the bit string present? And then is the list of RUs present, right? And then basically, if you're really, bad forwarding element, only a subset of these functions is supported. And voila, we get to a solution which I think is very flexible. You can build trees even with the worst of the hardware forwardings that we know, and hopefully, the better, vendor type of high-speed ASICs would be able to do both of it. But maybe even, let's say we go into data centers, which is all very dense, very high fan out. Maybe they would say, well, we're never implementing the SID options because all the trees are very short. So it turns back to be, in these environments, just the recursive bit string that we had in RBS. Next slide. Right, so where do we go from here? So yeah, we're writing the research paper up. And I would love for some reference code usable by others. This is, of course, not the full stuff we've done, but the seed plus. And I'm, of course, somewhat worried to just also look into these, business opportunities. So the whole AI into data centers, but that's kind of on a further track. I'll need to talk with ICE. So he was raising the concern. The original encoding was very compact by not including length fields, right? But that you get the length from the state itself. And I think it would lovely to have both options, right? If I'm at a data center, that is a very fixed topology. You know exactly what the bit string lengths are, so no need to include these fields. But yeah, if you go to an arbitrary network like a provider core, so I'm hoping that, the opportunity to say, well, even the length fields can be optimized away. If the control plane can tell you and you feel safe in a network like a data center, then the encoding becomes more compact. But that's a discussion I would like to have with him. And then, yeah, what's the target hardware, right? So I think that's again the big discussion for us. When I was talking with Jeff, for example, and the other Jeff, the NVIDIA Jeff. So basically the big difference in terms of how low can we go with these things, right? The the big buffer more expensive things like, you know, the good third-party vendor of chips from everybody, Jericho, would probably be able to do everything, but then we go to the lower end Tomahawk, right? So hopefully also the structure makes it easier to get into lower end ASICs. But yeah, our P4 code should hopefully be a good starting point reference. Yeah, I mean, I would love to present to Beer next time, right? This time was just purely because I had the conflict, and so luckily we had at least the student there, and then talk how we go from there, right? This is certainly very experimental, right? So I wouldn't dare to ask for anything more than experimental. We go, but if the IETF is interested in the scaling of Beer and especially making the bloody Beer TE stuff a lot easier, that would be great. So. Yeah, that was backup side.
Yeah, okay.
Presented it last time. Yep. Any questions? Thank you.
Thank you. Hitoshi.
Hi, this is a version 7 update of multiple upstream interface support for Agent PMLD proxy. The next. So actually, maybe we can rename this draft to the multipath support for because this is maybe more attractive for everyone. So please consider this one recognized extension of multipath support for the Agent PMLD proxy. Next, please. So this is a background. So it's actually it's a really well-known issue that the RFC 4605 does not support such much homing situation, and it's really common that the proxy has the different upstream interface to the same ISP or different ISP or even the different interfaces. So this is important to enable the IGMP embedded proxy device to use such kind of multiple upstream interface support and receive multicast packets through these interfaces. Next, please. So this page shows the objectives and the expected benefits. So IGMP embedded proxy device enables the reception of multicast session channels through the different upstream interface. This has a various benefits. For example, the flexible operation and, for example, the subscriber-based operation like client address space. So some business may want to distinguish the different clients for the getting the for providing the quality of the content or policy management. And also the channel-based upstream selection, one or more upstream interfaces is per channel session, and also the robust data reception. So this is something equal cost multipath. And also it's required to the backup interface, so upstream interface takeover, it switches inactive upstream path to another active backup path. So we had actually the requirement draft, the second bullet, but it was expired, and we already got some working group last call, but since we didn't have a strong interest about this kind of requirements draft, so AD asked us to something like merge or integrate the requirements information into this solution draft. So now I have been thinking about integrating the requirements part into our solution draft. Next, please. So we have two proposals. One is this draft. This intended status is informational because this introduced some static configuration. What is the motivation and how we can support the subscriber-based upstream interface selection, channel-based upstream selection, and the upstream interface selections can be per SG or STAG or even S-star basis. And also we can support interface priority-based upstream interface selection. And if there is no configuration or mismatch, we can use a default upstream interface. And we will also add some statement about SDN-like controller-based upstream interface configuration. But actually, my course thinks that it's better to provide more specific information about SDN-like approach in a separate document. So we have now thinking about it. And if you have some opinion about such kind of SDN-like controller-based approach, then please tell us. We may include this kind of controller-based approach inside this draft, or we can split to the different separate document. And the different one, the another one is actually the dynamic configuration. This intelligence data is proposed standard because it requires signaling-based configuration, which requires IGMP MLD extension. So we definitely need to get the consensus about such kind of protocol extension. So that's why the main aim is to divide our first one and the second one is that we have a different entity status. Next, please. So the calendar and the next step. My courser, Luis, already provided some academic paper with his members, and it's already presented in ICIN 2021. So actually, our initial draft was years ago, really years ago. So maybe we of course need to do the several improvement to define the default active interval to detect an inactive upstream interface and consider the interaction with signaling methods that is provided in a different draft. And maybe Young model specification of the Young model is also maybe required. But anyway, maybe it's time to ask you to that working draft adoption. That's all. Thank you.
Go ahead.
Jeffrey from Juniper. So there is a feature for PIM and MLDP, the MOFR. And then there is for BGPM APN, there is another RFC for upstream redundancy, where the egress PE may receive multiple copies of the same traffic from different ingress PEs, and then it will choose which stream of the packet will receive. So it seems to me that here we are basically the same problem. To which upstream interface you send the IGMP join or both, and when you receive traffic from on which interface you would accept the traffic. And to me, all this seems to could be local behavior. The proxy router itself just decide, I'm going to send it this way or that way or both. And then when the traffic comes, I'm going to accept here or whatever. So it seems to me that it's just really a local behavior. Maybe I missed something.
So what's your question?
He doesn't think it needs to be standardized. Is that right?
Right.
Yeah. He's saying that he thinks it should be a local behavior, and subsequently we wouldn't need to standardize it.
So again, the intended status is informational, and the biggest problem is 46.0. The current IGMP ML proxy doesn't support multiple upstream interface clearly. So this is a problem. So we'd like to break that kind of a limitation. Well, we don't propose this as a proposed standard. So that's why I said that I insisted that it should be informational. And of course, if we need some protocol extension as a dynamic signaling approach we provided, it needs the maybe standardization, but this draft doesn't aim to make any standardization.
Thomas Eckert, yeah, I mean, worst case, this is also, if this is an operational, method could as well go to MBOD if people feel it's not right for PIM, but I have no opinion right now.
Stig, so yeah, maybe it can be a local decision and a local implementation thing, you know, how to exactly do this. But I think it's good to document in an informational document and say, if you try to implement something like this, this is how you may do it, or things that you need to worry about, or so that, you know, implementations hopefully get it right when they implement it.
Right. Thank you.
By the way, I guess the original use case for this was multicast mobility, maybe 10 years ago or something.
Yeah, we may need to go back to the very, very historical issue.
Sunday on ZTE. In my opinion, I think that just like the two people just said that it's we can do it about through the configuration way or something other way. It's local configuration or local method. And the other things I think that if you want to standardize it, the most important thing is that it's very complex, because how do we know the customer want and there must many things can be carried through the IGMP drawing or something else. You must get from the customer, right? And you made your decision. So as I think if you want to standardize it, it's more complex than you want. So that's what I think. Yeah.
Yeah, so that's why I never promote this should be a standardized. And I agree that that kind of which interface or what kind of interface should be selected is really common to the PIM matter as well. So this doesn't provide any solution that which interface or what kind of interface must be selected for that, for what kind of streaming. So that kind of discussion, I agree that is really difficult, and it's this doesn't aim to provide such kind of information.
Yes, I think if it's just want to provide some guidance or some thinking about the selection, I think it's good because you can list some of
Sure.
Yeah, list some of your thinking. Yeah, I think it can be it can make some sense. Yeah.
Hold a second again. Yeah, I mean, you may also ask Nick or so. I think German Telecom, probably in the same way as I think Louis was Telefonica or so. I'm trying to remember.
Yeah, exactly.
They I think in the past they all have, maybe still have different upstream VLANs, one of which magically has multicast, the others don't. So I think it's a common deployment case in these service providers, and they all had their magic, how to build a router recommendation with you must use this magic VLAN number something in, whatever their requirement specification was for them. And I don't think that's very amenable if you want to build a multi-service provider home gateway. So I can easily see the importance of that use case, right? As I said, I have no clue whether PIM or MBOD would be better, but I don't even know why this shouldn't be standards if everything else that they're configuring into these routers when you attach them to service provider, ultimately, yeah, it may be some TR69, it may be Yang, I don't care, but if we just standardize it one way, they'll figure out if they use a different protocol than our Yang, like TR69, to kind of bring the same feature into that, right? So maybe you're even aiming too low with the informational.
Thank you for your comment. Actually, the Nick was or is the requirement draft cursor. So here, of course, the Deutsche Telekom or Telefonica, they really had similar issues, and they had some, let's say, something like a stress. And so we have been talking about the requirement, and then now again, that kind of requirement draft shall be included in this one. So I'm not sure how we can divide, or we should integrate the requirement draft into this solution draft or not. So we had a history. So I'm not sure. So there are several comments, and maybe Luis my cursor, he preferred to have still want to make it alive the requirement draft as well. But the previous AD had some comment about the less interest doesn't push the moving forward. So, well, I'm not sure how we can integrate the requirement draft into this one, or we should push the requirement draft first and then discuss about this kind of static solution and then go to the next step, which is a dynamic interface configuration, which requires a IGMP NLD extension. So we actually had 3 drafts. And this is a second one, static configuration, not a third one, which is a dynamic configuration. We had one requirement draft. So how we should do, I'm not sure.
Well, do you want us to do, per your request, an adoption on just this draft right now?
Yes, at this moment, because the requirement draft was already approved in a working draft, but again, it has had less interest, so we are terminating updating the requirement draft now. But anyway, so today, I'd like to ask to support this draft as a working group draft. And maybe next time we will present a dynamic configuration approach as well.
Sunny on ZTE, I think you should change the title of this draft.
How?
At first.
It's a much.
It's not a requirement.
Much
It's
past.
just, yeah, no.
Yeah, maybe. Thank you.
Do you have anything else on this one?
No.
Okay. Okay, thank you. So right now we have 4 that are in favor of adoption, 1 no opinion. So we'll follow up on the list and thank you very much.
Okay, thank you.
All right, Jeffrey, bringing us home.
Okay, so this is informational draft for multicast options in a source, segment routing network. It's specific for non-source routed options. The co-authors including me, Ice, Woman, and Yi Sung. Next slide, please. So again, it's informational. We present our thoughts so that we can discuss and consider those points. The source routed options are not considered in this document, not because they're not good. It's just, we're just not considering including them in the scope of this document. Beer, I do not consider it as source routed because it does not encode the tree or subtree. Okay, next slide. So when we talk about SR multicast options, we want to look at the principles of segment routing first. To me, the #1 principle of segment routing is that you do not have per tree or per tunnel states in the network anymore. You use loose or strict paths encoded in the packets themselves. The second principle or characteristic is that it's the optional use of controllers. The ingress routers may be instructed by the Godbox controllers, omnipotent, omniscient. Those controllers will how the packet should be steered. So those are the principles as I see. Next slide. So if you look at the principle #1, then there are 2 options here. One is ingress replication, the other one is beer. The ingress replication is simple, mature, but it's not efficient when it comes to replication. Still, it's applicable for certain scenarios. One example is that low rates or low fan outs, sporadic multicast flows. And when you do ingress replication, you can use both segment routing or non-segment routing paths. For example, IP paths, MPLS paths, or SRv6 paths, whatever. You just have the root of the multicast tree send unicast copies to the leaves. Beer allows you to do efficient replication without per tree state. So it's perfect solution for SR multicast. It sticks to the #1 principle of segment routing. And it works for all situations, but scenarios where convergence on the scale is critical, then those scenarios will benefit the most. It's interesting that both IR and beer, they are developed independently of SR. Next slide, please. So beer has got good protocol progress in IETF. We've got the base architecture, encapsulation, and signaling RFCs quickly, and we also have been working on extensions and brownfield deployment solutions. However, the deployment has been very limited due to a chicken and egg problem. Because it is new encapsulation and new forwarding, so it requires new ASIC or programmable ASIC. So we have operators who were very interested in beer, but they had to back off due to platform limitations. And once the operators back off, the vendors also back off due to unclear demand. So that's kind of chicken and egg problem that has been limited at the deployment. However, we believe that prime time is coming. We have ASIC capability from several major vendors across edge, access core, and platforms. And so the pioneering vendors and operators will help break the dilemma. We are also doing interop testing among the major vendors. Greg? Yep.
Greg Ravius. I just wanted to point out that we do have a major vendor with deployments active in customer networks, I think as long as 2 years now, but I'd have to ask someone directly to get them to respond.
Yeah. Okay, thanks. Next slide, please. So when we look at the #2 principle of segment routing, using controllers, so we have two options. One is that controller calculate the trees. The tree setup can still be using traditional signaling, but we can use controller to calculate that tree. And the next one is the trees that are both calculated and signaled from the controllers. SRP2MP is the first one there. It's part of this working group. And then the next option is using BGP signaling from the controllers for MLDP tunnel or IP multicast. So in case of BGP signaled MLDP, the only relevance to MLDP is the use of MLDP FAC as a tree identifier. This is a good option when you are transitioning from, for example, an MLDP-based MVPN and to where you don't want to use MLDP for signaling anymore. Next slide, please. So here are some considerations for SRP2MP. As Guman mentioned earlier, when we are using MPOS data plane on the replication nodes, the SRP2MP is very similar to MLDP or RSVP P2MP, because in your data plane, you basically have label-based replication. You have label in and label out. In the forwarding path, it's no difference. The difference is in the control plane. You have different tree identifiers or you have different signaling protocols. There is one point we do want to emphasize that with SRP2MP, you can avoid tree state on the non-replication nodes. So from your upstream nodes to your downstream tree nodes, you can have many hops. You can use tunnels. You do not need to establish those tree state on those tree nodes. So this is good for sparse replication situations. I also want to point out that PIM and MLDP actually supports that as well, but it does require you have PIM adjacency over tunnels, you have MLDP signaling over targeted sessions. But if you use SRP2MP, that is avoided by the use of the controller. Next slide, please. Now, some operators are moving away from MPLS. They just want to do SRv6 based forwarding. Then in that case, SRv6 P2MP, the tree node states is also like the MPLS case. In the MPLS case, we have incoming, outgoing tree identifying label. With SRv6 data plane, those labels are basically encoded as functional bits in the destination IPv6 multi-address in the SRv6 encoding format. In particular, the locator in SRv6 destination address will get a packet from one to the downstream tree node, whether that tree node is directly connected or had many hops away, there are many hops away. So that locator is sort of like the base label in the MPLS case. In particular, segment routing header can be used to explicitly steer the packet to remote downstream nodes. You can tell what exact path you use. So one thing here is that each tree node does need to update the destination address. So a new program or programmable ASIC is needed to support SRv6 P2MP. However, many hardware that supports SRv6 unicast already may be able to support SRv6 P2MP. But the older ASICs that is entirely SRv6 capable, that is out of luck. And in that case, pure IP v6 multicast can be used here. Because they both use the IPv6 header, so it could be a very good alternative when you have this nodes that does not support SRv6 P2MP. Next slide, please. And then we also have traditional situations, ingress replication, PIM or P2MP. They can still be used if they address the use cases without pinpoints. We mentioned earlier that plain old IPv6 multicast could maybe a better choice in some situations. So this is dependent on the operator's preference, because some operators, when they go to SR, at least for unicast, they remove LDP or RCVP for unicast purpose, but some may want to remove it entirely. They don't want to use it at all for multicast. But some operators may say that I'm fine with running MLDP or even RCVP to MP, even though I don't use LDP or RCVP for unicast anymore. I'm fine. So a key point to consider here is whether you want to use the controllers or not. If you want to use controllers, then yes, SRP to MP or BGP signals, MLDP or IP multicast from the controllers. Next slide, please. So this is a summary for the considerations of these options. I list them in the order that's what we believe is a good order to consider. So if you care about efficient replication without per tree states, and most of your replication nodes can support beer, then obviously beer is the #1 choice. If you cannot do beer, then the traditional multicast solutions may still be used if they work well, and especially you don't need to use controllers, or if you are fine with running those protocols after you get rid of LDP or RSVP for unicast purposes. And finally, if you do need to use controllers, or you do want to just get rid of those older protocols, SRP2MP is a good choice. Just keep in mind that they still have the per tree state on the tree nodes. Similarly, BGP signal, MLDP or IP multicast is also a good choice. So this is basically a summary of the considerations for all the options. Next slide, please. So discussions. These are just some thoughts we have. Some may be controversial, maybe different people have different opinions, but we want to put this out for information and for discussion. Thanks.
Personally, personally, I think this draft is very valuable for reading, and because it provides many recently technologies analysis here. So I think it's very valuable. And I just want to comment for the title because they said no source multicast. I think it's not a general calling here, right? So I think maybe we can change some little, yeah, about the title, yeah. Maybe it can be more explicit or something else, yeah.
Okay, this is actually a replacement document for previous drafts where we simply said SR multicast. The reason we called out non-source routed is because we did exclude the source routed options here. We know that there have been discussions on source routed options. There are good considerations there. It's just that we are not including that in our consideration here, not because they are not good, as I point out at the very slide. It's just that it's good to focus on the non-source routed options first. Yeah.
Yes, but maybe I'm wrong because I think that if we want to use source routing, maybe use it for TE, traffic engineering. So, so I think that if we can use general calling instead of the because that it really confused me non-source routing until I read the draft and I understand what it say. But just from the title, I can't get anything from it yet.
Okay, thank you. But again, we are not saying that source routed options are not good. Just one clarification.
Okay, thank you.
Yeah, Hitachi gone, but I will cut the line after that.
Very quick question. So, oh, I forgot. Well, my question is SLV6. So, sorry for my ignorance, but do you propose that SLV6 doesn't support the IP Multicast perfectly, or did you talk about the situation about multicast support in SRv6 community? So sorry, I'm not. I'm not a little bit confusing that. So what?
So
the relation with SRv6 and multicast.
So both SRVs, excuse me, both SRv6 multicast and plain old IPv6 multicast, they are all based on the IP address, IPv6 address. So when you need to look up, when we're trying to find how to replicate your traffic, there is no difference between SRv6 and IPv6. You can just treat it, the incoming v6 address entirely just as a v6 address, or you can just really look into the functional bits, but it does not matter. Now it's on the outgoing side with plain old IPv6 multicast, your destination group address does not change. But with SRv6 multicast, you do need to change your destination address on each tree node. That is not a problem if your router is already support SRv6, but for some older platforms, that may be a problem. So that's why I say that in some situations, you can use plain old IPv6 multicast instead.
Okay, thank you.
Any requests for us?
Right now, we are happy to just let it stay as is, and then we trigger discussions, and then eventually, if we have enough consensus on this, that people don't have problem with this, of course, we like to adopt this as an informational draft. But for now, we're happy to just trigger this discussion.
Great.
Yeah, some good documents.
Thank you. And thank you, everyone. Enjoy your weekend.
Yeah, thanks.
Thanks for being here. We were up against a popular BOF. So thank you for being here. Nothing. That's it. See you in Vancouver. No.